So let's take a look at how to write quadratic inequalities in two variables when we're given a graph. We know that because we're working with quadratics, we should be looking at the baseline of a quadratic function. Quadratics are given in the form y is equal to ax squared plus bx plus c. And since we're given a quadratic graph, we can choose 3 points, 1, 2, 3, which are given, and substitute values in and solve for a, b, and c. However, we should notice that we are given the vertex of this quadratic as well. So we can simplify the process by using the vertex form of a parabola, which is given by a times x minus p squared plus q, where p and q are the x and y coordinates of the vertex respectively. Well, the vertex here is going to be the point 0, comma 0, so we can sub those right into our quadratic equation. So we have y is equal to a times x minus 0 squared plus 0. We can simplify this to get y is equal to a, well, this is going to be x squared, and we are good to go. We just need to find out what is this a value right here. Well, to find this a value, we can choose any of the other 2 points that were given, substitute those into our equation, and solve for a. I'm going to choose the point on the right here. It looks like it's the point 1 in the x direction and 3 in the y direction. So I can put in 3 for y is equal to a times 1 squared. Therefore, a is just simply equal to 3. So we can use this to find the outline of the quadratic that we're given here. So we have y is equal to 3x squared. Now we should notice something. We're not dealing with an equivalency here. We are given a shaded region above a quadratic, and the quadratic is outlined in dotted lines. This means that we're looking at all the points that are bigger than the quadratic. So if this is the quadratic that is outlining everything, then in order to write the equality, or the inequality, we should be looking at all the points that are greater than this original quadratic, that 3x squared. We wouldn't use an equal sign unless we had a solid line that looks something like that. And that's quite simply everything that you need to do. Just choose a number of points that will give you a satisfying solution to the quadratic form. Let's take a look at another example where we're going to be solving a quadratic inequality in two variables. We're given 3 points on this graph that we can read right off of it. This top part is the vertex, and that is given by the point -1, comma 5, 6, 7, 8, 9. So we can once again use the form y is equal to ax minus p squared plus q, where the vertex is going to be -1, comma 9. So I can substitute these right into our equation for y is equal to x minus 1 is going to be +1 squared plus 9. Now all we have to do is find out what that a value is going to be. Well, to find that a value, I can use any of these 2 points right here. I'm going to choose the positive value, which is at 2, comma 0. It's a root, and substitute those into our original equation. So we're going to have 0 is equal to a, x is 2, plus 1 squared plus 9, and I'm going to be solving for a. So let's simplify that to be 0 is equal to a times 3 squared plus 9. Bring the 9 over to the left-hand side to get -9 is equal to a times, well, 3 squared is going to be 9. Then we can divide both sides by 9 to get -1 is equal to a. Therefore, a is equal to -1 in our original quadratic form. So we can say that y is equal to -1 times a plus 1 squared plus 9. But this would be the situation where we're only dealing with a quadratic line. The graph is not depicting a quadratic line. It's depicting a quadratic as well as the shaded region above. So all of our answers need to be greater than this original quadratic. And since we're also including that line, we can include an equivalency sign as well. So we can rewrite our solution as y is greater than or equal to negative x plus 1 squared plus 9. And that would be the final answer for writing an inequality to describe this graph.